All right, guys, as we proceed, guys, with the how we represent organic compounds. Remember, we said we can represent organic compounds using what? Molecular formula, structural formula, and also we can use what? A condensed structural formula. So now, let me give you more examples now on how to write these three types of formulas. Therefore, now I'm just going to continue with the basic alkanes until we understand the basic formulas that are necessary for us to understand. Right. I'm going to make an example using pentane. And maybe now I'm going to just show you a short notation on a condensed structural formula. I'm just going to change it a little bit, not change it, but just to show you another way on how they can write the condensed structural formula. Now, let's look at pentane. So pentane, this is pentane. This is the IUPAC name. We all now know it. So pentane, this is the IUPAC name again. So this is IUPAC name. So pentane, it has the same general formula as all the alkanes. So all the alkanes, they have C N H 2N plus 2. So that is the general formula of alkane. So now, if we want to determine the molecular formula of pentane, remember pent, it means that the compound, it has 5 carbons. Yeah, it has 5 carbon. Pent, it means 5. So therefore, to determine the molecular formula of this one, remember we're going to substitute here on N, where N stands for the number of carbons. So how many carbons on pentane? There's 5. That means we're going to say 5 like this. Say H, and where there's N, you're going to put 5 again, close the bracket, say plus 2. Now, when we simplify this, therefore, this is going to be C, 5H, then this is going to give us 12. So this is the molecular formula. Yeah, this is the molecular formula. So now, how do we write the structural formula of pentane? So we can write it in this manner. Therefore, structurally. So how do we write the structural formula? Therefore, we can write it as C like this, but it must have 5 carbons. Therefore, this is how it's going to look like. So this is pentane, therefore all around this bond, therefore we can add the hydrogens like this. So this is how it's going to look like, structural formula of pentane. Now remember, on the structural formula we show all the bonds. So now if we write a condensed structural formula, a condensed formula, therefore what we simply do, we just condense these formulas, these bonds. Therefore, that means we're going to write C. This stands for the first carbon here is going to be CH3. And the second one is CH2. We have another CH2. There are how many CH2s there? This H. There are 3. Then the last one is going to be CH3. The last carbon here has 3 hydrogen. This is how we're going to write it in a condensed formula. Now we can write this in a short notation also. A short notation on this, how do we write it? Therefore, instead of keep on repeating CH2s, so what do they do now? Sometimes they can write it like this, say CH3, and then when it comes to these CH2s, they can write just one. They can just write one CH2 like this, say CH2, and then from there, instead of repeating this, they can say 3, and then say CH3. This CH3, and then it's the last one here. So these they are, that means here there are 3 CH2s therefore before you can come to this CH3. So this is how it can also be written in a short notation. In pentane, the condensed formula of pentane. Maybe let me give you another example here. Let's take for an example of, after pentane we know that there is hexane. Let's use hexane. So hexane, obvious guys, it has the same general formula. So it's going to be CN H2 plus 2. So now to write the molecular formula of this, if we want to say hex, it's 6. So it's going to be 6 H2, then close that, then this is 2. And then now what will be the molecular formula of this, therefore? So the molecular formula of this is going to be C6H, and then it's going to be 14. So this is how we're going to write the molecular formula of hexane. So structurally, guys, obvious, you know that it's going to be something that will look like this. You can maybe write it before I finish it, just write it on your side, and you will check mine. You can pause the video all the time, try to write it on your own, check if same thing, you can get to the same conclusion. And maybe you can also write the condensed formula before I can write it. Pause the video, write the condensed formula, and write the short notation. So now this is how hexane is going to look like. 1, 2, 3, 4, 5, 6. So this is how it's going to be looking like structurally. So we cannot condense this structural formula, guys. So you show everything here. You must show everything structural. But now in a condensed formula, therefore, this is going to be CH3, CH2, 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 and CH3. So 1, 2, 3, 4, 5, 6. So there's 6 carbons there. So this is how it's going to look like. So normally it's how it's going to look like, but they can represent it in this manner. Write it in a short notation. They can first write but CH3, then they open the bracket and then they say CH2. Now instead of repeating all the CH2s, they can say only 4 and then say CH3. So this is how they can write it in a short notation. Right. I think I'm gonna leave it here for. But if you have any questions, guys, or you still want me to cover more of these types of or expression, how to express organic compounds, then just send me comment, and then I will continue with maybe with alkenes how to write their short notation. But I'll remind you later on. But guys, make sure that you like and subscribe on this channel, guys, and make sure that guys you become a part and a member of this group so that you can get more updates on time. Right. Thank you very much. See you on the next one.